Good morning, everybody. Welcome to another edition of Discovery. It may be the afternoon, it may be the morning where you are, so I'm grateful you're joining us from wherever you're joining us. For those of you joining us for the first time, Efficiency Canada hosts Discovery every 2 weeks, and the sessions are really meant to bring the sector together, people interested in energy efficiency, and we try to highlight new research, findings from pilots, projects, relevant innovations. So it's really meant to learn together. So I am Alison Mostowich. I'm the Director of Engagement at Efficiency Canada, and I am joining you from Mohkinstsis, which is the Blackfoot word for Calgary, meaning elbow. So in the spirit of reconciliation, I acknowledge that I live, work, and play on the traditional territories of the Blackfoot Confederacy, the Tsuut'ina, the Nakota, the Métis Nation within Alberta District 6, and all the people who make their homes in the Treaty 7 region of Alberta. So before we get started, I'll just remind everybody that we'll have a bit of a presentation. So Josh, as you can see, is going to hang out with us and talk to us for about 20 minutes. And then we'll have a great question and answer period at the end. So you can use the question and answer button at the bottom of your screen. And there's an upvote function in there. So if you see a question you really like it. And I generally ask the questions that have the most likes first. So if you don't see a question that you like, then go ahead and answer your own or ask your own, and we will make sure we get it in there. So today we have with us Josh Lewis, who is VP of Energy Engineering with Nerva Energy. And he is going to walk us through just a huge project that they did, 85 multi-residential buildings, 10,000 plus units, and talk about how they advanced energy conservation and sustainability in those buildings. So thanks, Josh, so much for being here. Welcome.
Appreciate it, Allison, for that introduction and sharing my screen. And let's get started. So welcome, everybody. I really appreciate you sharing your lunchtime with me today in Efficiency Canada. And as Allison alluded to, we're here to talk about the largest multi-residential smart building conversion in North America, covering 85 buildings, 13.3 million square feet, and 10,000 suites, generating millions of dollars in annual energy savings, a 16% return on investment, and probably most importantly, a 36% GHG reduction within this portfolio of buildings. I'm pleased to be able to have the opportunity here today to walk you through the details about this project that was executed in 2023. So let's just start with some facts. The reality of it is that data from hundreds of multi-residential buildings shows us here at Nerva that these buildings have up to 50% energy waste in the way they're currently operating. And that this waste can be eliminated while achieving positive financial returns. And it really leads us down a path, which I'm going to get into today, about how we're going to decarbonize building stock like this, not just multi-res, but really we can apply this to almost any types of buildings. And there's some advantages to taking a stepped process. So let's understand who Drewlo Holdings is. It's probably not a name that most people have heard of unless you live in the London, Ontario area, where they have 50 buildings. Drewlo is actually the 10th largest owner operator of multi-residential buildings in Canada. So they have 50 buildings in London, Ontario, but their buildings actually span in Southern Ontario from Sarnia down to Burlington, being centered on London. And Drewlo has been around many years. They're privately owned, family operated, started in the 1970s, where you can see they built around 7 buildings. And since then, they've been continuously building buildings, operating buildings to get to their current portfolio of around 85 multi-residential buildings. And these buildings have been built with various mechanical systems over the years. You know, the two most popular ones being buildings with hot water heating, but DX cooling or traditional type of in-suite cooling for the suites. That's mostly been on the lower rise buildings. But they've also built 35 hot water heated, chilled water cooled, fan coil buildings, very traditional type of build for larger multi-residential buildings. But they've got some outliers too as well. They've got 8 buildings with hot water baseboard radiators, no centralized cooling. The 2 buildings with PTAC units, which are traditionally more commonly seen in hotels, not multi-residential, although you do find them from time to time. They also have 5 buildings with electric baseboard heating and no centralized cooling as well. So, common types of buildings, but they have a full swath of all the different types of systems that you would expect to see in, historical rental multi-residential buildings in Ontario. And what does that break down to? Well, they have a lot of mechanical equipment, 228 boilers, 36 chillers, 30 cooling towers, 96 makeup air units, 158 domestic hot water heaters, and 1,065 mechanical pumps. So there's a lot of equipment within these 85 buildings in total that really needed to be optimized for them to achieve their goals. So as I alluded to at the beginning of the webinar, let's talk about this path, right, to optimal performance outcomes. And this is the way that NERVA works with our clients in order to advance their portfolios to both higher energy efficiency, but also decarbonization as well. And it starts with optimization first. It then moves into conservation and eventually gets to conversion or fuel switching. So let's look at a little bit more of those details. So what is optimization, or at least within the scope of this multi-residential portfolio? So really what we're looking at here is optimizing the effective systems that they have in the building today. The boilers, the chillers, the cooling towers, the makeup air units, and the fans and the pumps. To be perfectly honest, multi-residential buildings are some of the most easiest from a mechanical perspective to optimize because they're very straightforward. They may be small buildings, they may be large buildings, but they share common systems, they share common operating patterns. And what we've been able to find here at NERVA and what we delivered as part of this project was there's typically a 20 to 35% reduction in HVAC load that can come out of optimizing the existing building systems. This typically leads to a 15 to 30% reduction in GHG emissions. So right at this first step, the utility liability can be reduced as well as the operating expenses, because you got to keep in mind here, as traditionally in multi-res and almost all buildings in the country, the cost for the heating and the cooling of the building and the ventilation of the building as well through the makeup air units is borne by the owner operator of the building. It is not paid for by the tenants. That's traditionally. Typically, tenants have only paid for the electricity usage within their suite, which mostly boils down to plug loads and appliances and those types of things. So there's a financial impact here to the owner operator for reducing the heating cooling load, and those financial returns go directly back to them. That increases net operating income, net asset value. And walking through this step gains performance insights, which for effective reporting, leading into the second step of the process for this portfolio, which is conservation. So now that optimization has been done and the automation systems within the building have been upgraded, and I'll get a little bit more than that in another slide here. Now we're in the conserve mode where we have all kinds of data coming in for this building now at a much higher level than most multi-res buildings have ever achieved. This allows to find conservation steps above and beyond the initial optimization, including even reducing capital expenditures for replacement equipment or end of life cycle equipment, right sizing equipment because the data is now available to do that, but also maximizing the operational savings through load efficiency, finding opportunities for heat recovery, and really getting us on this path to cost effectively translate away from fossil fuels. And that's where we get into the next step here, which is conversion, getting into zero carbon buildings, right? So we know we have to get off natural gas. Drewlo realizes they have to get off natural gas for primary heating of their buildings. That is the only realistic path forward, given the carbon tax, given where we expect commodity prices on natural gas to go over the next 10, 15, 20 years. One thing is they do have a very long-term outlook, right? And if we look at the outlook of energy performance and GHG reduction in alignment with the life cycle of mechanical systems, which is, at least 20 years in any type of commercial building, we start to see the benefits of optimization and conserving now as we move into the conversion step, right? And converting these buildings, as we make these steps forward, are going to lower operating costs and practically eliminate carbon tax liabilities. Again, enhancing property values because they'll have more of a green premium associated with them rather than a brown discount, and really positioning the portfolio for compliance with current and future regulatory and environmental standards. So what did this look like more specifically for the Drewlo portfolio? So like I said, it started with this full mechanical optimization, boiler loop temperatures, chiller and cooling tower operation, the introduction of VFDs where they currently weren't present before, and the optimization of the makeup air units and the fresh air delivery to the hallways of these buildings. Next, it's about identifying energy abusers. And let me state a fact that we've come to find out through the implementation of this type of methodology through hundreds of multi-res buildings. Oftentimes, we find that 5 to 10% of the residents in a multi-res building can be up to 40% of the annual HVAC load, and hence the annual HVAC energy usage. And the reason is that we call these people the abusers, and they're typically wasting energy through either having set points on their thermostats way too high or way too low, depending on the season, and leaving their windows open for extended periods of time while their heating and cooling is operating. That can't be tolerated. It's a waste. It doesn't provide, really good comfort in the end, but people operate that way. And I really feel it's subconsciously because they're not putting a value on that heating or cooling because they're not paying for it. Therefore, certain people will abuse it. Well, as part of the optimization step within these buildings, that abuse has been curtailed primarily through the identification of the abusers through the data, and then the installation of window and door sensors, which essentially prevent a tenant from running their heating or cooling while the window or door is open in order to prevent that waste. Also included in this step is the submetering of the major mechanical systems to inform the phase 2. Phase 2, we're working with Drewlo on that now, the strategic capital investments for their end-of-life equipment. We have to think about this today. If we put a new boiler in today, we're going to be probably operating that boiler for 20 years. So that means 2044. And the reality of it is, do you want to be paying for gas for a boiler for primary heating in 2024? I would suggest the answer in most cases is probably no. So this is where this long-term look in line with the mechanical replacement cycles really becomes value added. And certainly adding heat recovery to buildings with central exhaust. I feel this is a very untapped energy conservation measure. In the Drewlo portfolio, there's not a lot of buildings that have central exhaust, but for any multi-res building in the country with central exhaust, typically on the roof, heat recovery to the makeup air system is one of the most obvious energy conservation measures that should be retrofitted almost immediately. Then in phase 3, which we are already working with Drewlo on certainly their new portfolio and then getting into their existing buildings this year, is introducing heat pumps and geothermal solutions. But one of the key things here is that, heat pumps, geothermal is expensive. It's more expensive from a capital cost than, boilers and chillers, conventional boilers and chillers. But because we've optimized and conserved, we now have a cost-effective path for conversion, because we've driven 20, 30, sometimes 40% of the heating and cooling load out of the building through the first 2 phases. Now the conversion to a fully low carbon or a partial low carbon heating system using heat pumps becomes much more affordable. This is why this path really works for the majority of buildings, and it really is the right path. We cannot just switch into fuel switching right away, because going to phase 3 without phase 1 and 2 will probably not financially solve. So, how do we pull this together in multi-res buildings? Well, it really comes down to smart thermostats and temperature sensors throughout the entire building using real-time wireless communication, because trying to do this type of system, whether new construction or retrofit, and trying to use wired devices produces a cost barrier that really can't be overcome because wires are expensive. Wireless is actually relatively inexpensive these days, and the technology has matured to the point where it's very reliable. Combining that with NERVA's professional engineering services for the continuous commissioning, the ongoing optimization, the 24/7 monitoring, and really making sure that those buildings are performing in conjunction with the energy performance dashboard, which informs us as well as Drewlo in this case, or any client, the real-time utility consumption, the mechanical plant performance ratings, and getting alarms and notifications whenever the building falls out of the expected operating parameters from an energy demand point of view, from an energy usage point of view, from a temperature point of view, and making sure that those alarms and notifications are actuated in real time and dealt with in real time. So how did this look like from a project roadmap perspective? So it really started with engaging the client, right? Establishing their motivations, their desired outcomes, their cassette goals. We then did a pilot with Drewlo, 433 King Street in London, Ontario, full building optimization. And through that building, we were able to drive a 43% reduction in energy usage for that building. Very good results. Then it started with performance validation. That extended the program to 6 more properties, installing mechanical submeters, validating that the savings were repeatable, and the forecasted savings were repeatable. The return on investment was there. Step 4 was then portfolio evaluation, right? That kind of happened in parallel with step 3, but collecting all the past historical utility information for all their buildings, the size of the buildings, the age of the buildings, the types of systems in the buildings. Certainly there were site visits involved with that to really understand where the best opportunities were in the portfolio. And then that turned into turnkey project delivery, right? So NERVA is an engineering firm, but we really pride ourselves on taking hold of projects all the way from concept through design, implementation, commissioning, warranty, and guaranteeing the outcomes of the results. Really offering that one-stop shop to make sure that the project is successful from an energy, from a financial GHG point of view, and that we take full responsibility for every step of the process. So in the case of this portfolio rollout for Drewlo that they did last year, the client actually mandated a 12% ROI on a 15 to 20% GHG reduction. That were their minimum targets that NERVA guaranteed for. But the reality of it is the outcome validation shows that we're delivering a 16% ROI with 36% GHG reduction. So exceeding client targets and obviously making them very happy because we do that. But there's still more continuous optimization here. That 24/7 monitoring is in place, monitoring, making adjustments, sending them maintenance requests when we notice things that are out of spec or boilers that have failed, and really having that day-to-day communication to make sure that their entire portfolio buildings are operating where we promised they were and where they want them to operate. And now into phase 2, now we're using all this performance data that we're collecting on real time to both inform their new construction, where they're already implementing both air source and ground source heat pump systems into some of their new builds, and looking at the retrofit play for their existing buildings about how, in conjunction with the mechanical life cycle replacement, they're going to cost effectively implement different types of heat pumps into their existing building portfolio as the end of life of the equipment comes up, so that by over the next 20 years, they get to maybe not zero carbon operation, but very low carbon operation. So what do we see as the quantifiable benefits and impacts of this? Well, certainly they've lowered energy costs and decreased GHG emissions. And I'm going to have some more metrics here for you in a second. Environmentally, they're already reducing their use of fossil fuels, but also less demand on the grid. And that's something that sometimes we maybe miss in these discussions. But when we're switching to heat pumps, Unless the building was primarily electrically heated before, in which case it would have with baseboard heaters, in which case it would have a fairly large electricity connection size. But if it's a natural gas building, it probably didn't. And as we move buildings towards heat pumps, we have to optimize first because we have to be good consumers of the grid. And honestly, there's already grid restraint capacities in many areas across the country. So, the most we can do to optimize and conserve before converting is a real benefit to the grid. And, even if we're looking at this, say, if we were talking about a university campus and decarbonizing it, you don't start with the district energy plan. You start with the buildings first and optimize and conserve as much as you can before you redesign or upgrade your district energy system, because that's the best path from an investment and an environmental perspective. Also, too, though, now Drewlo has full visibility into their mechanical portfolio with real-time alarms, performance reporting, and they have a level of visibility they've never had before. So let's look at some of the real numbers here. So over 1,500 mechanical systems were optimized during this project. We've removed 3.1 million kilowatt hours of annual usage from Ontario's electrical grid. We've also reduced Drewlo's consumption across these 85 buildings, 10,000 suites, by 1.3 million meter cubes of natural gas per year. This ultimately, together, when you consider the gas plus the CO2 equivalent from the kilowatt hours in the grid, Ontario's grid is fairly clean compared to some other jurisdictions in Canada, but still, all that combined together is a 36% portfolio-wide GHG reduction just through optimization and conservation before fuel switching has even occurred. So, just briefly to talk about the timeline here, right? The fact of the matter is these 85 buildings were retrofitted and the results proven out under less than 1 year. It was actually about a 10-month rollout for the core part of this project. It goes to show the pace and scale of what's possible, right? And what is possible, I guess, specifically, at least in terms of multi-res buildings across the country. There is a huge path here for getting a lot of greenhouse gas reduction out of these buildings before fuel switching in order to hit our 2030 targets, right, as a country. Then, really looking at making sure that we're doing fuel switching, at least partial fuel switching for any new builds, and really looking at the conversion, though, of the existing buildings going on to 2030 plus, using the optimized results to right size those heat pump systems and really in the end just solve to a financial return on investment that can be supported when we're talking about a for-profit type of company. So what really are the pillars of success here that allowed NERVA to work with Drewlo and to really make this a reality? Right? It starts with a fully integrated firm like ours, engineers, HVAC experts, project delivery team, building automation experts to really get this out there, but also accountability and certainty, right? Pre-establishing what the minimum outcomes needed to be, putting an energy performance guarantee into place. Like I said, they were looking for 12% return on investment. We actually delivered 16. So definitely under-promised, over-delivered. That's what we like to do. But also the sustained performance, right? We can get it, we can get into a building, we can retrofit it, we can get out, but who's really looking at it from a continuous commissioning perspective, from an optimization perspective, from a performance reporting perspective? Well, we've kept that responsibility and we'll continue to keep that responsibility going forward in order to make sure their portfolio stays where it's at, because that's our expertise, not their expertise. So working collectively with them, we can bring together the best of both worlds. So that's the project. Once again, thank you for joining this webinar today. I look forward to taking care of answering any questions that I can, technical or otherwise. And I think I will pass it back to Allison now for those.
Thanks, Josh. That is a massive project. That's really cool to see the roadmap that you used as well as the savings. So we do have some great questions in the background. It's funny, I was writing down questions and then the questions that were popping up were very similar. So let's get into it. So I think the first question that a lot of people had was, you had mentioned that Drewlo is a family-owned business, and people are curious about, okay, so this sounds like a huge project. How did they finance it? And then did they use any incentives on top of that? So can you talk a little bit about that?
Yeah, absolutely. So they did finance this in multi-million-dollar project internally. So it was completely based on their internal savings, internal cash flow. And incentives certainly were part of the project. This project got, I don't have the exact number off the top of my head, but it was definitely several $100,000 worth of incentives from the Save on Energy program here in Ontario, and also from Enbridge's incentive programs as well. So both on the electricity and the gas side. But I would suggest, I mean, if we think about project financing as a whole, maybe not every company can self-invest, self-finance this type of project, but I would encourage anybody else to think about the Canadian Infrastructure Bank Building Retrofit Initiative program. This type of deployment would fit excellent into the CIB BRI program, offering those low-cost loans backed by the government and distributed through aggregators, typically like Sofiac is one of them, Blackstone, Johnson, Honeywell. There's a whole bunch out there. So depending on the size of the project, a portfolio could either go directly to the CIB and get funding. In fact, CapREIT just announced yesterday they've taken $70 million to retrofit 60 buildings in their portfolio under that program. So the money is definitely out there. There's no doubt about that. Whether it's a small portfolio or a larger portfolio, there's a few different paths, but that should not be a concern for moving forward.
Can we explore that a little bit more? I had a question about economies of scale because I think it affects not only the funding, but it also affects the cost that you can get the different upgrades for. So, these types of return, is it reasonable for, like, if somebody had a single, class B, class C building, are these reasonable returns for people? And do you feel like it is still a good investment?
Actually, well, I mean, when you say Class B and Class C, that kind of spurs to my mind. You're more talking about commercial buildings rather than multi-residential buildings, right? We usually use those. ABC is usually refers to a commercial, not multi-res. But yes, actually. So, I mean, obviously, the solutions for commercial buildings with this type of optimization and conservation retrofit are different, right? Commercial buildings don't operate like, or don't have the same type of HVAC mechanical systems that multi-res buildings do, but similar savings can be achieved. And NERVA is working on projects like that as well. One of the most common things, actually, and I mean, this is a little bit off topic to Drewlo, but I will say this, is like one of the most common things that we need to optimize across the country is the standard gas-fired DX rooftop unit. There are millions of those across the country. Like when we think about office buildings, we're typically thinking about the tall glass towers. And I love those buildings and they're interesting. But the bulk of our Class B and Class C space is typically done just with standard rooftop units. And there are great solutions out there to just optimize those that actually, to be honest, can actually produce even better return on investments than this. Because really, when it comes down to those buildings, it's about runtime hours, deep nighttime setbacks, optimum start, and CO2 on demand control ventilation. That's really the big one. That's not something you do in multi-res. It's more particular to commercial spaces and rooftop units or those types of systems. But CO2 DCV can now be implemented at scale at a reasonable cost with minimal maintenance. Just doing that alone across our Class B and C buildings could have a huge impact to our 2030 targets.
Great, thanks so much. Okay, so this question has a bunch of upvotes, so I'm going to talk about it. So somebody wondering if you could comment on the possible building envelope improvements as we move to fuel switching to size heat pumps and make sure the loads are correct. How much did that play a role in this project? And just will continue to play a role, I guess, as we retrofit more buildings?
Yeah, it's a great question. And there was no building envelope improvements in this project, and there's not projected to be any building envelope improvements on any scale going ahead for the phase 3 or conversion part of this portfolio. And let me just explain why. But the problem is that building envelope improvements in occupied buildings are very difficult to solve financially. That is just the reality of it. We are starting to see some innovative projects around that. I would refer people to Windsor Essex Community Housing. They're currently doing an EnerFit or passive house retrofit of an occupied MERB in Windsor, Ontario. The building is right between the casino and the Detroit River. We're still working on that building, but that is going to be a very interesting project because they are doing the retrofit with people in place. But that's in the social housing space. And they kind of have different metrics that they're solving for. But generally, building envelope improvements on existing buildings are hard to financially justify right now. There's more of a path for the mechanical optimization, the controls optimization, and then just moving to the conversion. Now that may change. I'm hoping that we get more prescriptive, lower cost, locally built, low embodied carbon building envelope retrofit solutions, but unfortunately not there. Now, in new build, I will just say this, if we're going to do anything on the building envelopes right now, outside of jurisdictions that are forcing us to do them, like Toronto with the Toronto Green Standard or BC with the BC Step Code, everybody's got to keep air tightness in mind. If you build a code compliant wall window system, but improve the air tightness significantly, even to passive house levels, I would say that is the biggest lever in new construction, well beyond, for example, the upgrade from double to triple pane windows.
Thank you. Just so many considerations there. Okay, so let's talk about, you mentioned the carbon tax. How significant was that in sort of pushing this project forward? And it sounds like there's a belief that the carbon tax will continue to exist, or some tax of some kind. So talk a little bit about that.
Yeah, so this is something I talk about all the time. I mean, we have to understand what the carbon tax is. It's the market-oriented solution to getting us off of carbon, whether that's in buildings, whether that's in transportation, whether that's in industry. So the idea behind a carbon tax is generally if we tax carbon, that will make the low carbon or no carbon solutions more financially viable. And as we know, ultimately, most things solve back to dollar signs. So, it's an alternative regulations like the Toronto Green Standard and the BC Step Code, which push buildings, into the low carbon world by regulation, not by the carbon tax. So if we look at, what the standard forecast for carbon tax is today that both we use and actually even the Canadian Infrastructure Bank uses, it's assumed that the carbon tax is going to get to $170 a ton by 2030. And it's actually going to stay at $170 a ton past 2030. So that's the forecast we used for Drewlo. That's the forecast the Canadian Infrastructure Bank uses. And when you see the carbon tax getting up to those levels, it really does help the financial equation. But I'll caution everybody here. The economists have said that we need to get the carbon tax to $300 to $500 a ton by 2040, 2045, probably at the latest, in order to have the true impact we need across buildings, transportation, and industry to really meet our climate change commitments as a country. So, but at the same time, the carbon tax is obviously political. So there's a political impact to that, and politics can drive changes to it. Look, no one has a crystal ball on the next election. No one has a crystal ball on the carbon tax. Heck, nobody has a crystal ball on what commodity price escalation is going to be. But we have to, if we're going to solve to projects today, we do have to agree on like the metrics we're going to use, commodity increase, carbon tax increase, because if you don't agree on that, then you can't solve to a return on investment. Is what we agree on going to be the actual case? No, really, that's all outside of all of our control, but it is a good grounding that I encourage people to have those discussions in order to set themselves up for success like this.
Absolutely. Great guidance. Thank you, Josh. Okay, so I love this question because it's kind of about behavior and it's about the people component of these projects, which you can't ignore. And I think you did allude to in your presentation. So someone just noting a small subset of tenants in the building can be the largest consumers of energy. So besides adding sensors to fenestration to control the thermostats, did you use any other ways to, I guess, encourage good behavior, or, can you recommend any?
As part of this project, I do not believe Drewlo engaged with their tenants any other way. And I mean, I'm not saying that is not a potential path, right? I mean, I think we should be educating not just the tenants in multi-res buildings, we should be educating the entire general public about the impact that our choices, our day-to-day choices have on energy usage, on carbon emissions, right? Even in single family homes, right? Does every single family home in the country have a good thermostat schedule to set back their temperature when either they're at work during the day, if there's no one in the house, or definitely at night? I would say that's not necessarily true, and there's a lot of education to do to inform everybody, right? But again, maybe that I think conversation happens easier when the impact of making a change directly affect the person's pocketbook who's making the change. In the case of this Drewlo's portfolio and actually the bulk of multi-res buildings, the tenants do not pay for their heating and cooling. And unfortunately, like I said earlier, it's kind of a subconscious failing of humans. We tend to not put a value on something we don't pay for. So it's subconscious. It's not something that most people actively do. We're not generally actively trying to waste. But unfortunately, sometimes it's sometimes hard to uncover some of those, to change some of those basic instincts. So certainly Drewlo is promoting what's happened here. They're certainly educating their tenants on their new smart thermostats in their suite. The tenants definitely see the impact because, they got a new thermostat. In the case of abusers, they also got the window door sensors. But even just the basic thermostats now, they can't set really high temperatures on the thermostat or really low temperatures. So every tenant in the portfolio has already seen an impact. And I hope that with communication as well as that hands-on feel, that everybody in the portfolio really starts to maybe wake up a little bit and start to really understand that their day-to-day choices do have an impact on the environment.
Mm-hmm. Absolutely. My master's is in behavioral science, and we have a psychological bias for loss aversion. So if there is no loss, then there is no attention paid to it. So yeah, you absolutely nailed it there. So I'm curious, and maybe this is a bit of a tougher question, but we've seen some criticism of some of these, I would say even CIB projects, and then some of these big portfolios, they make retrofits and then they are pricing some tenants out. So I'm just curious, is this something that came up as a challenge in the Drewlo projects, or even just, some general commentary on, is this something that, you think is coming up for a lot of landlords and how they're starting to deal with it? Yeah, because I think we're just starting to see increasing criticism and especially the media, and there are some campaigns right now from nonprofits about agreements that should be in place with CIB funding. So yeah, I'm just curious to hear your thoughts on that, whether generally or related to the project.
Well, that's not terribly my area of expertise, but I do know a little bit. I'll say a couple things. First of all, Drewlo has done none of that. Drewlo is not increasing rents because they're saving money or anything, like that. None of that is going on within their portfolio. They look at this as, because the benefits of the 16% return on investment are direct into their pocketbook, that is good enough for them. And so, but on the CIB side, actually, the CIB now, through the Building Retrofit Initiative, is actually anybody in the multi-res sector who is taking the CIB funding is required to agree that there will be no rent evictions or above market rent increases or anything like that. Because you're right, I think there was a little bit of a problem with that at the beginning, but from the CIB's perspective, they've now clamped down on that.
That is so excellent to hear. I'm grateful that you're able to share that. Okay, so just switching gears a little bit more to the technical side, we have a question about the heat recovery in buildings with central exhaust, and just wanting you to explore that a little bit more.
Yeah, absolutely. So this is something that has bothered me for many years, but there's a lot of older multi-res buildings across the entire country that were built with central exhaust systems, right? Because there's two ways to kind of build multi-res. You can either build them with in-suite exhaust, meaning that the range exhaust, the dryer exhaust, the bathroom exhaust is directly vented out through the sidewall for every suite. It's an independent system. Or you get these exhaust riser stacks that typically pull the exhaust air from every suite to the roof and then exhaust it out the roof. And I can't tell you how many hundreds, well, thousands of buildings are that have these central exhaust systems. And you look at the roof of these buildings and they'll, let's just, use an example here. They have 8 exhaust fans and 2 makeup air units. And the exhaust fans are literally anywhere between 10 to 30 feet away from the makeup air units on the roof. And the way that these buildings have been designed and operated since they were built, some of them as early as the 1950s, is that you're pulling this room temperature exhaust air out of the buildings 365 days a year, 24 hours a day, and venting it to the atmosphere. And you've got the makeup air unit right next to it, which is at least heating, if not cooling the air, the incoming air in the summertime, and delivering it to the hallways to pressurize the corridor and to ventilate the buildings. The fact that these buildings were ever built with these systems that could be so easily connected together on the roof to provide up to 90% heat recovery kind of blows my mind a little bit. But the reality of it is heat recovery equipment does have a capital cost associated with it. It reduces operating costs, obviously, once you install it. But I guess for many decades, the cost of natural gas being so cheap is that the heat recovery really couldn't solve anymore. Well, that has fundamentally changed. That has fundamentally changed for new construction now since several years back, especially in regulated areas like Toronto, like BC, where, the energy codes, the above code energy requirements force you to put heat recovery on new buildings, whether that's centralized or in suite. It can be done either way. But on these existing buildings, we have thousands of MERVs that need 1 or 2, in most cases, heat recovery units on the roof. And at that point, we can capture at least 75%, if not 90% of the heating cooling energy that we're pulling out of the suites and pass that back into the makeup air stream. And basically, it's not free. I mean, we're still losing a little bit of percentage there, but basically we can heat and cool that makeup air for very low cost and very low carbon emissions compared to what we were doing before. It's an obvious upgrade. We're going to see a lot of those over the next number of years. And it is really a key path in that step 2 of the process here to conserve, because you would never size a new heat pump, zero low carbon heating system for a multi-res building that you are not doing centralized exhaust heat recovery on. Again, though, that only applies if the building is centrally exhausted, because doing in-suite heat recovery retrofits, while possible, are a lot more complicated. You're in the tenant space. There's a lot more work to do. I think we're going to start to see a lot of those too as well, but those are going to be later down the road.
I'm wondering if it would be helpful for everybody to hear from some of the pilots and the projects that are going on and just talk about like tenant engagement and how that worked and what went well for them and what didn't. So if that's something that you'd like to see on a discovery session, send me a note. I think that could be a really cool topic. So keep that on the back burner. Thank you so much, Josh. Again, we have run into the constraints of time, which we do every week, and there's still questions left unanswered. So I just encourage everyone, if you have a question that you would like to chat with Josh about, reach out to Nerva. As you can see, Josh is just an unbelievable wealth of information, and we're so grateful you were able to join us today, Josh. So thank you.
Yep. Thank you very much, Allison. And thank you to everybody who attended.
So I'll just mention before we leave, we're here every 2 weeks. So next week, we're taking a bit of a different path. So we try to highlight some different individuals that are in energy efficiency and their career paths. So if you know anybody that is interested in learning more about energy efficiency or someone's career path and how they got into energy efficiency, these are really great sessions to direct them to. I assume many of you work in energy efficiency or are interested, and that's why you're here. So a little bit of a different audience, but I encourage you to, encourage your networks to join if they are interested. So this was recorded. This will be on YouTube in probably about a week to a week and a half. And if you'd like to reflect on it, I encourage you to go to our YouTube channel. And thank you again. Happy Friday, everyone. We'll see you in 2 weeks. Bye.